Good morning, class. In today's class, we will study about the properties of integers, page number 9 of your book. So before that, what is integer? As we all know that the numbers which are positive, negative and including 0 are called the integers. Natural numbers are the counting numbers 1, 2, 3, 4. And after that, if we subtract two same natural number, then we get the 0, which includes in the set of 0 and the natural number is called the set of whole number. Then integer are those numbers when we subtract a smaller number. When we subtract a larger number from a smaller number, then we get some negative numbers. So to represent negative numbers, we use the term integers. So integers are the set of negative natural numbers 0 and you can say simply negative natural number and whole numbers are the set of integers. Then come to property of up to this this is the introduction to of integer. Now come to properties of integer. First properties is closure property. What is closure property? When you add two integers, you will get an integer. So by adding two integers, we will get a integer. These are called the closure property under addition. Similarly, if we multiply two integers, then we get an integer. So this is multiplication property, the closure property under addition and multiplication. Okay, when we come to subtraction, when we subtract two integers, we will get an integer. Okay, so closure property works under addition, multiplication, subtraction. But when we come to division, this property does not exist. That means if we divide two integer, we will get an integer. We will not get an integer, we will get a rational number. You can see this example. -7 divided by 3 is equal to -7 upon 3, which is not an integer. This is a rational number, which is in the form of P upon Q. So what is the conclusion of it? Follows from the above observation that integers are closed under addition, subtraction and multiplication, but not under the division. Okay, you have to keep this in your mind that closure property comes under, closed under addition, subtraction and multiplication, but not under division. Okay, second property is commutative property. What is commutative property? Commutative property is come to this: a plus b is equal to b plus a. See some examples. +5 -7 is equal to -2. -7 plus 5 is also equal to -2. Okay, so this is true for addition, multiplication and but not for the subtraction. See, 4 minus 6 is equal to -2 and 6 minus 4 is equal to only 2, not -2. So subtraction does not comes under commutative property. Come to these points. It follows that addition and multiplication are commutative for the integers, but subtraction and divisions are not commutative for the integer. In the case of division, 6 upon 2 is equal to 3. But if you divide 2 upon 6 is equal to 1 upon 3, which is these two terms, these two integers are even 1 upon 3 is not an integer, not equal. So commutative property comes under only addition and multiplication, not for the subtraction and the division. Okay, now come to third property, that is identity property. Identity property means you have to add any digit or multiply any digit and the result is same, then you can that number, that digit is the identity property for that operation. For the example of addition, in the case of addition, if you add 0 to any number, then you get the same number. So 0 is the additive identity for the integer. In the same way, if you multiply 1 with any integer, then you will get the same result. So 1 is the multiplicative identity for the integer. But this is not true for the subtraction or division, because 4 minus 0 is equal to 4. But 0 minus 4 is equal to minus 4, which is not equal to. So for 0 is not subtractive identity. In the same way, if you divide 4 upon 1 is equal to 4, but 1 upon 4 is not equal to 4. Okay, so 1 is multiplicative identity, 0 is the additive identity, and there is no additive identity for the subtraction and division. Okay, next, fourth property is associative property. This is your associative property. A plus B plus C is equal to A plus B plus C. Also, A into B into C is equal to A into B into C. Okay, there are some examples. If we solve this expression, we will get the minus 6. If we solve this expression, we will also get the minus 6. That means A plus B plus C is equal to A plus B plus C. Okay, this is also true for the multiplication. Okay, now is it true for the subtraction? Let's check. 9 plus 5 minus minus 1, 9 plus minus minus plus 5 plus 1 is 6, that is 15. But if we change the brackets, 9 plus 5 minus minus 1, so this is 14, minus minus plus 1 is also. Let's see some more examples. Okay, A and B are the integers. This is the multiplication. Associative property holds good for the multiplication, but is not hold for the division, and this is not true for the. This is true for the subtraction, addition, but not for the division process. Okay, you can take any example and you can prove this property, associative property. Okay, next, distributive property. This is the perfect expression to represent the distributive property. We have three figures: triangle, square, and the circle, and between them there is a multiplication and addition. So how will we distribute it? Multiply into square plus multiply into circle. You can take any three integers and you can prove this property. Okay, so for all integers A, B, C, is this the property? Multiplication distribute over addition. Multiplication distribute over subtraction also. If we replace this addition sign with the subtraction, then we will also get the result same. So multiplication distributive property, or you can say multiplication distribute over addition as well as subtraction. Okay, so revise all these examples, study all these examples for practice more. In the exercise, you have to prove these properties. Okay, that's all for the today. Thank you. All the best.